Section 14.6, the chain rule. First, we discuss the chain rule for two variable functions. Then we discuss the chain rule for multivariable functions. Then we do implicit differentiation with the chain rule. So let's do a quick review from chain rule from in a calculus of one variable. If y is equal to f of x and x is equal to g of t, then the composition y equal to f or g of t, which is f of g of t is a function of t. The chain rule says that y prime of t is equal to f prime of g of t and g prime of t, or equivalently, dy dt is equal to dy dx times dx dt. So what if we have functions of more variables? For example, we have x as function of t, y as a function of t, z as a function of x and y. And so z becomes a function of f of x of t and y of t. Basically, input will be one variable, the output will be one variable, and so you think, how do we take the derivative of that? Basically, respect to t. Then, in principle, the derivative z prime of t should depend on the derivatives dx dt, dy dt, and the partial of z respect to x, partial of z respect to y. Something to note in the chain rule is that x was function of one variable, y was function of one variable, but z was function of two variables. So when we're implementing the chain rule, we use the notation accordingly. If the derivative is multivariable function with respect to one of the variables, it's a partial. Otherwise, if it's all single variable, it would be a derivative. So let's state the multivariable chain rule. The multivariable chain rule, first case. Suppose z is equal to f of x and y, and x is a function of t, y is a function of t, are differentiable functions. Then z equal to g of t, that is f of x of t and y of t, is a differentiable function of t, and derivative of z with respect to t is going to be, so derivative of z with respect to t, it's not the partial because z is the function of one variable, is equal to the partial of z with respect to x times derivative of x with respect to t, and plus partial of z with respect to y times derivative of y with respect to t. In the Lagrange notation, the formula is g prime of t equal to f sub x of x and y times x prime of t plus f sub y of x and y times y prime of t. So that's the other notation for partials and derivatives. Idea: changing t causes both x and y to change, which each cause the change in z. The chain rule formula actually records the total changes in z due to a change in t with contribution from both x and y. The multivariable chain rule, example 1, calculate derivative of z with respect to t if z of x and y is x times y, and x of t is equal to cosine of t, and y of t is equal to sine of t. So according to chain rule, derivative of z with respect to t is equal to partial z with respect to x times derivative of x with respect to t plus partial z with respect to y times derivative of y with respect to t. And that is, it's important when you're doing the calculations, what the output is going to be a function of t. So it's important to convert x and y into function of t after calculation. So derivative partial of z with respect to x is y. Derivative of x with respect to t is negative sine of t. Derivative of z with respect to y is x. Derivative of y with respect to z is cosine of t. This is not function of t only. So replace y by its value in terms of x. And then replace x by its value in terms of, replace y by its value in terms of t, and x also. So it's negative sine squared of t plus cosine squared of t. Now, at this point, so you found the derivative with respect to t in terms of, you found the derivative of z with respect to t, but z is a function of x and x and y are functions of t. So why couldn't I written z in the beginning as a function of x and y? As a function of t. So now, how do we do that? We replace x by cosine of t and y by sine of t. Then derivative calc one way is going to be a product rule, derivative first times second, and derivative of second times first. And again, you end up with the same value that you ended up in the first time. We start a concept called the chain rule tree. So right now, with the first chain rule that we learned, it's not difficult to figure out what terms to write. But when the chain rule gets more complicated, you have to basically know all the branches all the terms that happens, and the tree helps understand those branches basically. Okay, so let z be function of x and y, x function of t, y function of t. The pieces of formula for dz dt corresponds to the branch in the tree, and so you start from z. Then z has two variable, is a function of two variable, x and y, and x and y are both functions of t. So you go from z to the input of z, and then from the inputs of z to their own input or inputs, and then you will have this branch and you will have that branch. And so the first branch is the partial, it's partial of the top with respect to the bottom of the branch, partial of z with respect to x. This one is partial of, and then derivative of x with respect to t, because only one branch goes out instead of two or more. Then here partial of z with respect to y, and derivative of y with respect to t. And so you multiply one branch and you add it to the other branch. So that's multiplication of each section, and then you add to multiplication of this branch, each sections of this branch, and that gives you the derivative of top variable to the bottom variable.